Hello class, this is lesson 2 on proportional relationships. This is on page 6 in your textbook. Our essential question is, how do we know if two quantities are proportional to each other? And how can we recognize a proportional relationship when looking at a table or a set of ratios? Pause the video and copy down the essential question. Example 1. Pay by the ounce frozen yogurt. A new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabella's family weighed their dish, and this is what they found. 12.5 ounces cost $5. A 10-ounce cup of frozen yogurt cost $4. A 5-ounce bowl of frozen yogurt cost $2, and an 8-ounce bowl of frozen yogurt cost $3.20. The cost is proportional to the weight. What this means is everybody will be paying the same cost per ounce, and we know this because we can divide the cost by the total ounces, and it will tell us how much that person paid per ounce. So the cost per ounce in the first set of numbers, 5 divided by 12.5, and that gives us 40 cents. In the second set, we have 10 ounces for $4. $4 divided by 10 ounces equals 40 cents per ounce. In our third set, we have 5 ounces. The cost is $2. $2 divided by 5 ounces equals 40 cents. And the last person's frozen yogurt, 8 ounces for $3.20. So $3.20 divided by 8 ounces equals 40 cents per ounce. What is the cost per ounce? 40 cents. If I know the number of ounces, how can I determine the cost? So in this case, we knew the number of ounces and the cost, and we were finding out how much it cost for 1 ounce. In this question, they're asking, if I know the number of ounces, how can I determine the cost? We know that each ounce costs 40 cents. So 1 ounce is 40 cents. 2 ounces would cost twice as much. 3 ounces would cost 3 times as much. So we're multiplying the number of ounces times the cost per ounce. You are multiplying the number of ounces times the cost per ounce. The next question, what does 2.5 mean in the context of this problem? Well, first let's find out, where did 2.5 come from? 2.5 comes from dividing 12.5 divided by 5. Let's draw a line. 12.5 divided by 5 is 2.5. 10 divided by 4 is 2.5. 5 divided by 2 is 2.5. And 8 divided by $3.20 is 2.5. So if you're doing the division problem the other way around, the answer is 2.5. When you do the other problem and you divide the other way, what you're finding out is not the cost for 1 ounce, but you're finding out how much yogurt you get for $1. So if you're dividing by ounces, you find the cost for 1 ounce. If you're dividing by the money, you're finding out how much yogurt you get for $1. So 2.5 in this problem means the ounces divided by the cost is 2.5. So 2.5 ounces for $1. In example 2, a cooking sheet. In the back of the recipe book, a diagram provides easy conversions to use while cooking. So in our table, we see that we have cups and we have ounces. And we see that 1 cup is equal to 8 ounces, and 2 cups is equal to 16 ounces. And it says the ounces are blank to the cups. Well, if you have the proportional amount, then it will change at the same rate. As you increase the number of cups, you will increase the number of ounces. So what we want to know to tell if it's proportional is, does this change at the same rate? So here we look from 1 to 8, and we're looking for a multiplier to see if the multiplier is the same for those numbers. So if we went from 1 to 8, we would have a multiplier of 8. You could also go the other way and say that you have a divisor of 8. Going from 2 cups to 16 ounces, that has a multiplier of 8. Well, 1½ times 8 is 12, and a half of 8 is 4. And since the multiplier is 8 for all of these pairs, then the number of ounces are proportional to the cups. In exercise 3, during Jose's physical education class today, students visited activity stations. Next to each station was a chart depicting how many calories on average would be burned by completing the activity. In the chart, we see that the time, in 0 minutes you burn 0 calories, in 1 minute you burn 11 calories, 2 minutes requires 22 calories of energy, 3 minutes requires 33 calories of energy, and 4 minutes you need 44 calories of energy. Is the number of calories burned proportional to the time, and how do you know? Yes, the number of calories is proportional to the time because the number is multiplied by the same number, 11, to find the calories burned. If Jose jumped for 6.5 minutes, how many calories would he expect to burn? So we're wanting to know if the number up here was 6.5, then what would the number be down here for calories burned? Following the pattern of using a multiplier of 11 calories for each minute, you would multiply 6.5 times 11 to find that answer. So Jose would expect to burn 71.5 calories, 6.5 times 11. Example 3, summer jobs. Alex spent the summer helping his family's business. He was hoping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. Alex wonders, if I continue to work and earn money at this rate, will I have enough money to buy the gaming system by the end of the summer? To check his assumption, he decided to make a table. He entered his total money earned at the end of week 1 and his total money earned at the end of week 4. Are Alex's total earnings proportional to the number of weeks he worked, and how do you know? It means to be proportional if he's earning the same amount of money every week. So that's what we want to figure out. So we know that in 1 week, Alex earns $28. So first we can go back to 0 weeks and say that that is $0 because he has not earned any money. And our multiplier is $28, $28 for 1 week. So if he's working twice as long, he's earning twice as much. So we multiply by $28. 2 weeks times $28 per week. And that gives us $56. I'd like you to complete the rest of the table. Remember to multiply the number of weeks times $28 per week to find the amount of money earned. Again, 3 weeks times $28 each gives you your total. So pause the video and fill in the rest of the chart. Now check your answers. 3 weeks is $84. 5 weeks is $140. 6 weeks is $168. 7 weeks is $196. 8 weeks is $224. Are Alex's total earnings proportional to the number of weeks he worked? And how do you know? They are proportional because he is earning the same amount of pay each week, $28. You can see the extension down here. This is an equation that says y is equal to 28x. So looking at our table, where did that y and x come from? Our number of weeks is the x variable, and the total earnings is the y variable. And this is the multiplier that is used, times $28 times $28 times $28. So the multiplier to get from x to y is $28. When you multiply x, the number of hours, times 28, you get the answer of y, which is the total earnings. In summary for the lesson 2, measures in one quantity are proportional to measures of a second quantity if there is a positive number k, so that for every measure x of the first quantity, the corresponding quantity y is given by kx. The equation y equals kx models this relationship. A proportional relationship is one in which the measure of one quantity are proportional to the measures in the second quantity. In other words, there is the same multiplier used for every pair of x and y.